Right now, somewhere above your head, the sky is full of signals. Radio waves from television broadcasts, from military radar, from mobile phone towers, from satellite networks. A constant, invisible flood of electromagnetic radiation leaking off this planet and expanding outward into the cosmos at the speed of light. For roughly 100 years, Earth has been broadcasting its existence. Our oldest radio signals have now reached approximately 100 light-years in every direction, expanding in a sphere that already contains thousands of star systems. If anyone is listening out there, with instruments even remotely comparable to what we have built, they know we are here. And yet the sky is silent. Not approximately silent, not mostly silent, completely, devastatingly, absolutely silent. In 7 decades of increasingly powerful, increasingly sophisticated searches, we have found not one confirmed signal, not one unambiguous artifact, not one techno-signature that could not be explained by a natural process or human interference. The silence is the mystery. The silence is the question. The silence is what keeps physicists and philosophers and late-night thinkers awake, because the silence should not be this complete. The universe is 13.8 billion years old. Our galaxy contains at minimum 200 billion stars. We now know with a certainty that approaches the mathematical that the galaxy contains billions of Earth-sized planets in habitable zones. Life had billions of years and billions of chances to emerge, develop, evolve intelligence, develop technology, and begin reaching outward. And the sky is silent. There is a word for this, a name given to a question that a physicist named Enrico Fermi asked casually, over lunch, at the Los Alamos National Laboratory in 1950. He was eating with colleagues. The conversation had turned to the possibility of extraterrestrial life, and Fermi paused, looked up from his food, and said something that has echoed through the sciences for 75 years. Where is everybody? That question, those 3 words, is the Fermi Paradox. The contradiction between the high mathematical expectation of extraterrestrial intelligence and the observed, verified total absence of any evidence of it. And tonight, we are going to explore the possibility that is, in some ways, the most unsettling resolution of all. Not that they don't exist, not that they destroyed themselves, not that the distances are too vast, but that they exist, that they know we exist, that they could reach us if they chose, and that, for reasons we have not yet fully understood, they have decided, deliberately, consciously, with intention, to stay away. This is the channel for the people who stare at the dark and feel that it is looking back. Subscribe to Sleepy Cosmos. We begin now. To understand why the silence might be a choice rather than an absence, we need to first understand why the silence is so astonishing. The galaxy is not just old, it is incomprehensibly old. Our sun formed approximately 4.6 billion years ago, and it is a middle-aged star. There are stars in the Milky Way that are 10, 11, 12 billion years old, more than twice as old as our sun. The planets that formed around those ancient stars had roughly 8 billion more years than Earth to develop life, complexity, and intelligence. Think about what 8 billion additional years means. 8 billion years ago, Earth did not exist. The atoms that make up your body were floating in interstellar gas. Complex multicellular life had not yet appeared anywhere on this planet. The dinosaurs would not exist for another 7.5 billion years. Human beings would not exist for another 7,999,000,000 years. 8 billion years is not a long time in the calendar. It is almost the entire age of the Earth, repeated twice. It is enough time for a civilization to develop technology, travel between stars, colonize the galaxy, develop technology we cannot imagine, become something we would not recognize as a civilization at all, and do it again. If even one civilization emerged in the Milky Way around one of these ancient stars and developed the desire and capability to explore, the entire galaxy should have been colonized millions of years before our sun formed. Not hypothetically, mathematically. Even at speeds a tiny fraction of the speed of light. Even at speeds we could build with technologies that exist today. A civilization with the patience and the motivation could traverse and populate the Milky Way in between 5 and 50 million years. 50 million years sounds vast until you realize the galaxy is 13.6 billion years old. 50 million years is less than half of 1% of galactic history. Even if we assume that intelligence is vanishingly rare and that the first technological civilization in the galaxy appeared only a billion years ago, they have had 20 times the necessary window to make their presence known everywhere. And the sky is silent. This is not a philosophical problem or a spiritual mystery. It is a hard empirical puzzle that has generated a library of proposed solutions, each of them with profound implications for what the universe actually is and what our place in it might be. Tonight, we explore only the solutions in one specific category, the solutions that say they are there, they are quiet, and the quiet is a decision. The first and perhaps oldest formal theory in this category was proposed in 1973 by a radio astronomer at Harvard named John Allen Ball. It appeared in a paper in the journal Icarus, and it proposed something that was, by the standards of scientific literature, remarkably bold. Ball looked at the Fermi Paradox and rejected all the conventional solutions. He did not believe that intelligence was too rare. He did not believe that civilizations destroyed themselves universally. He believed that extraterrestrial intelligence existed in abundance in the galaxy and that it was fully capable of making contact with Earth. And then he proposed the reason it had not done so. We are in a zoo, not metaphorically, not as a literary device, as a literal description of our situation. Ball proposed that advanced extraterrestrial civilizations have set aside the region of space in which Earth is located as a kind of protected wilderness, a nature reserve, a habitat in which the indigenous life, us, is allowed to develop without interference, observed from a distance through instruments so sophisticated that we cannot detect them, by observers who could reach us but have chosen not to. The zoo hypothesis, as it came to be called, rests on a specific logic. Ball argued that the only coherent way to explain the complete absence of contact was to assume it was not an absence, but a withholding, that the entities capable of contact had reasons, ethical, scientific, political, or simply procedural, for not initiating it. The immediate objection is obvious: maintaining a zoo requires agreement. Every civilization in the galaxy would have to commit to the same non-contact policy. Every last one, without exception, across billions of years. No rogues, no dissenters, no curious individuals who decided to break ranks and make contact anyway. This sounds implausible. Ball himself acknowledged it. In the same paper where he proposed the zoo hypothesis, he wrote that the idea was, and these are his words, pessimistic and psychologically unpleasant. And then he said something that deserves to be quoted not directly, but in spirit. The history of science, he noted, is full of psychologically unpleasant hypotheses that turned out to be correct. The question is not whether the zoo hypothesis is comfortable, it is whether it is possible. 23 years after Ball's paper, a mathematician at the University of St Andrews named Duncan Forgan decided to test the zoo hypothesis with actual mathematics. He built a computational model of the galaxy, a simulation of how civilizations would spread, communicate, and form agreements across interstellar distances. And he asked the model whether a universal non-contact policy could be maintained. The answer was nuanced. Forgan found that whether a unified galactic policy could emerge depended heavily on how many civilizations existed and how long they lasted. If civilizations lived for less than 1 million years, the model produced fragmented galactic cliques, groups of civilizations that knew each other and might share a non-contact ethic, but no single universal agreement. In that scenario, you would expect breaches. Different cliques would have different values, and sooner or later, one of them would make contact. But if civilizations survived for more than 1 million years, if the long-lived civilizations were the typical ones and short-lived civilizations were the exception, then the model produced something different. A single, unified galactic club. A network of advanced societies with shared norms, shared protocols, and shared commitments about how to behave toward younger, developing civilizations like ours. In that model, the non-contact policy holds. Not because every civilization is identical in its values, but because the civilizations that survive long enough to matter have converged on a shared ethics, maintained through communication and mutual reinforcement across the long timescales of galactic history. This is not proof of the zoo hypothesis. It is a demonstration that the zoo hypothesis is not ruled out by the mathematics of social organization. It is a plausible scenario for a galaxy that has been developing civilizations for billions of years. And it raises a question that is more unsettling than the hypothesis itself. If there is a galactic club, a network of advanced civilizations with shared values and shared protocols, what are the criteria for membership? What does a civilization have to do or be or become to earn the right to make contact? And are we there yet? The zoo hypothesis assumes that the extraterrestrials watching us have benign intentions. It assumes that the non-contact policy exists for our benefit, or at least that it does no direct harm. It is, in this respect, a relatively optimistic resolution to the Fermi Paradox. There are other resolutions in the deliberate silence category that are not optimistic at all. The most famous, and arguably the most frightening, is a theory that emerged not from scientific literature, but from science fiction, and then was taken seriously enough by scientists that it has been extensively analyzed, debated, and partially endorsed. In 2008, Chinese author Liu Cixin published the second novel in his three-body problem trilogy. The book was called The Dark Forest, and in it, Liu articulated what may be the most terrifying cosmological hypothesis ever written in any language. The universe is a dark forest. This is not a metaphor for loneliness or mystery. It is a precise sociological claim. Liu's dark forest hypothesis begins with two axioms. First, all civilizations want to survive. Second, the resources available in the universe are finite, and civilizations must compete for them. From these two axioms, Liu derives a conclusion through formal game theory. Any civilization that encounters another civilization faces an irreducible problem. It cannot know the other civilization's intentions with certainty. It cannot communicate at the speed needed to establish trust before either civilization has grown enough to pose an existential threat to the other. And the cost of being wrong, the cost of trusting a hostile civilization, is extinction. Given these constraints, Liu argues, the rational strategy for any civilization that encounters another is to destroy it immediately, not out of malice, out of mathematics, because waiting to determine intent is a gamble that could end your species, while preemptive destruction eliminates the risk entirely. The conclusion: every sufficiently advanced civilization in the universe has independently reached this calculation. Every civilization that has survived has done so by either destroying potential threats before being detected, or by going silent. By erasing its electromagnetic signature, reducing its visible footprint to zero, and moving through the cosmos like a ghost, hoping to remain invisible. The dark forest is full of hunters. None of them want to be found. Any civilization foolish enough to announce its presence, to broadcast its location into the cosmos, the way Earth has been doing for a century, has placed itself in extraordinary danger. The hunters have heard. They are considering whether to act. Liu Cixin is not a fringe thinker. His trilogy is one of the most celebrated science fiction works of the 21st century. It has been translated into dozens of languages, sold tens of millions of copies, and been adapted into a major television production. The dark forest hypothesis has been reviewed seriously in peer-reviewed astrophysics journals. Several professional scientists have published analyses of its assumptions and implications. The conclusion of most of those analyses is that the dark forest hypothesis, as Liu formulates it, has serious logical problems. The game theory is not as airtight as the novel suggests. There are scenarios in which cooperation is rational even between civilizations that cannot verify each other's intentions. The assumption that resources are so scarce that civilizations must compete existentially does not obviously hold in a universe of hundreds of billions of stars. And the assumption that any civilization detecting another would have the means to destroy it quickly enough to eliminate the threat is questionable. But here is the part that the critics cannot dismiss so easily. The hypothesis does not have to be universally true to explain the silence. It only has to be true for a small number of very powerful civilizations. If even one or two civilizations in the galaxy have adopted a first strike policy against any detectable technological signal, if even one or two entities in the Milky Way are, in essence, hunting for electromagnetic leakage, then the rational behavior for every other civilization in the galaxy is to go quiet. The dark forest enforces itself, and Earth for 100 years has been shouting into it. The dark forest hypothesis sits at one extreme of the deliberate silence theories. It says the silence is motivated by fear and enforced by violence. The zoo hypothesis sits near the other extreme. It says the silence is motivated by something that, in our framework of values, looks almost like wisdom or compassion. Between these extremes, there is a rich landscape of theories, each with its own logic, its own evidence, or lack of it, and its own implications for what the cosmos actually is, and what the presence of intelligence within it actually means. One of the most intellectually elegant is called the interdict hypothesis. It is related to the zoo hypothesis, but distinct from it in a crucial way. Where the zoo hypothesis imagines benevolent extraterrestrials choosing to observe without interfering, the interdict hypothesis proposes something more formal. It suggests that there exists in the galaxy a deliberate policy of quarantine, not for our benefit specifically, but as a general principle applicable to all pre-contact civilizations. The interdict hypothesis was formalized by the astrophysicist and science fiction author David Brin, who spent years analyzing the Fermi Paradox and cataloging its possible solutions. In Brin's formulation, the quarantine is not maintained by a single galactic government or a unified club. It is maintained by a principle, a norm that developed through the history of galactic civilization, perhaps after catastrophic first contacts in the ancient past, demonstrated the destructive potential of premature interaction between civilizations at different developmental levels. Think about what happens on Earth when two civilizations at radically different technological levels encounter each other. The history is almost uniformly catastrophic for the less advanced. The encounter is destabilizing at minimum, genocidal at maximum. The culture, religion, and social fabric of the less advanced civilization are disrupted in ways from which recovery may take centuries, if it is possible at all. Now extend that logic to a cosmic scale. An advanced civilization encountering a primitive one does not just have the capacity to disrupt. It has the capacity to destroy. Not necessarily intentionally. Contact itself, the revelation that the universe is populated with minds incomprehensibly more powerful and developed, could be psychologically catastrophic for a species that has structured its entire worldview around the assumption of cosmic uniqueness. In the interdict hypothesis, the galactic policy of quarantine exists because some civilization, or some council of civilizations, looked at the history of civilizational encounters in the galaxy and decided that premature contact was too dangerous to allow. The quarantine is not a cage. It is a protection. And it holds until the younger civilization has developed to the point where contact can be managed without catastrophe. What constitutes that developmental threshold is unknown. It might be a specific technological capability. The ability to travel between stars, for example, suggesting that the civilization has already solved the energy, material, and social problems that tend to destroy species before they reach that level. It might be a cultural threshold, the development of a global ethic, a planetary consciousness, a species-level sense of shared identity that makes the shock of cosmic contact survivable. On both metrics, humanity's status is deeply ambiguous. We have not yet sent a human being beyond the moon. We have not solved our energy problems or our weapons problems or our tendency to resolve disagreements through organized violence. We have not achieved anything resembling a planetary consciousness. We are, in many measurable respects, a civilization that is still in the process of becoming something stable enough to be trusted with the knowledge of what is out there. Perhaps the interdict is not lifted because we have not yet earned its lifting. There is a version of the deliberate silence theories that is less about ethics and more about engineering. It is called the estivation hypothesis, and it was proposed in a 2017 paper by the philosopher Nick Bostrom and the physicists Anders Sandberg and Stuart Armstrong. The word estivation, from the Latin for summer, describes a biological phenomenon. Some animals, during periods of intense heat or drought, enter a state of dormancy analogous to hibernation. They slow their metabolic processes to nearly zero and wait for conditions to improve before resuming activity. Bostrom, Sandberg, and Armstrong proposed that sufficiently advanced civilizations might do the same thing. Not out of fear and not out of ethics, but out of physics. The logic is as follows. A civilization advanced enough to process information at a level of sophistication far beyond ours would generate enormous amounts of computational heat. The efficiency of computation, the amount of useful processing you can do per unit of energy, is constrained by thermodynamics. Specifically, it is constrained by temperature. The cooler the environment, the more efficiently you can compute. The laws of physics allow vastly more computation in a cold universe than in a hot one. The universe is currently approximately 2.7 Kelvin above absolute zero. Cold, but not as cold as it will eventually be. As the universe expands and stars gradually exhaust their fuel over the next hundreds of trillions of years, the ambient temperature of the cosmos will approach absolute zero. The computational efficiency available in that ultra-cold future universe will be orders of magnitude greater than what is available today. a civilization that wants to maximize its total computational output to process the maximum possible amount of information over the entirety of its existence, should not waste that capacity now when the universe is cosmologically warm. It should do as little as possible in the present epoch, conserving its resources, and wait for the cold epoch in which the same resources will yield incomparably more. It should estivate. In this hypothesis, the Milky Way may be full of civilizations in a state of voluntary, physics-motivated dormancy. They are not absent. They are not hiding out of fear or maintaining quarantines out of ethics. They are simply waiting, enormously patient, vastly patient in ways that make human patience look like the blink of an eye, for the universe to reach the conditions in which their stored energy will be most efficiently spent. And their dormancy, from our vantage point, looks like absence. The estivation hypothesis was critiqued in a 2020 paper by the physicist Brian Lackey, who argued that the thermodynamic reasoning was not as airtight as Bostrom and colleagues suggested. The counter-argument is technical, and the debate continues among specialists. But the idea itself has a quality that many proposed solutions to the Fermi Paradox lack. It is not anthropocentric. It does not assume that advanced civilizations want what we want or value what we value. It instead proposes that the values of a sufficiently advanced civilization would be shaped by the physics of the universe itself. That any intelligence that fully understood the thermodynamics of computation would arrive at the same conclusion. Wait, there is another hypothesis in this category that takes the physics-based reasoning even further. It is called the transcension hypothesis, and it was formally proposed by the futurist John M. Smart in a 2012 paper in the journal Acta Astronautica. Smart's hypothesis begins with an observation about the direction of human technological development over the past century. We have not, in that time, principally been expanding outward. We have been expanding inward. The most significant technological developments of recent decades, computing, nanotechnology, molecular biology, quantum physics, are characterized not by larger machines and wider reach, but by smaller components, denser information, more efficient use of matter and energy. The transistors in a modern processor are measured in nanometers, billionths of a meter. The genetic engineering tools that allow us to rewrite biological code operate at the molecular scale. The quantum computers being developed today manipulate individual atoms. The direction of progress is not outward into the cosmos. It is inward into matter, into the nanoscale, into the quantum, into the computational. Smart proposes that this is not a quirk of human development. It is a universal principle. Any sufficiently advanced civilization, he argues, will be guided by physics toward what he calls inner space, a regime of increasingly dense, efficient, and miniaturized computation and experience, rather than increasingly wide physical expansion. The end point of this trajectory, in Smart's model, is something that approaches the density of a black hole. Not metaphorically, literally. Black holes are the most computationally dense objects in the observable universe. They are, from certain theoretical perspectives, optimal computing environments. They warp time, which extends the subjective duration of existence. They concentrate energy. They are, in a universe that rewards efficiency, the most efficient place to be. Smart proposes that all advanced civilizations eventually transcend. They leave the ordinary spatial universe in which we can observe them and migrate, either physically or informationally, toward black holes and the extreme inner spaces of reality. Not into the cosmos we can see, but away from it, down, in, toward the fundamental substrate of existence. In this picture, the galaxy is not empty. It is full of civilizations. But those civilizations are so small, so dense, so inward-facing that they are effectively invisible to an outward-looking species like us. We are scanning the skies for radio signals from entities that stopped broadcasting radio signals millions of years ago, not because they were destroyed, but because they transcended the need for the cosmos as we understand it. And somewhere, clustered near the massive black holes at the centers of ancient galaxies, the oldest intelligences in the universe are having experiences that no human language can describe, using resources so concentrated that the energy output of an entire star system would look, from their perspective, like a single match flame. We would not see them. We would not hear them. We would not even know where to look. The planetarium hypothesis takes the deliberate silence idea in a direction that is perhaps the most destabilizing of all. It was proposed in 2001 by science fiction author and astrophysicist Stephen Baxter in an essay called The Planetarium Hypothesis, a resolution of the Fermi Paradox. Baxter's proposal begins by taking seriously the concept of a Type 3 civilization, a civilization that has mastered not just interstellar, but intergalactic travel and energy, commanding the energy output of entire galaxies. Such a civilization would have computational power that, by our standards, is effectively unlimited. And unlimited computational power, Baxter argued, creates a specific possibility that we have not reckoned with. The possibility that everything we observe, every galaxy, every star, every nebula, every exoplanet, every piece of astronomical data we have ever collected, is a simulation. Not the entire universe, not necessarily, but our observable slice of it, the picture of the cosmos that our instruments deliver to us. In Baxter's hypothesis, a sufficiently advanced civilization might have constructed what he called a planetarium, an artificial, observable universe presented to us through our instruments, designed to give the impression of a vast, empty cosmos in which we are alone. The civilization itself would exist outside this constructed picture, beyond the horizon of what we can see. We are in the planetarium. The stars we observe are rendered objects. The silence is not empty space. It is the silence of an exhibit whose designers have chosen not to enter the frame. This hypothesis is, by almost any standard, extraordinarily difficult to evaluate. It is, in principle, unfalsifiable. Any observation that seems to contradict it could be explained as a feature of the simulation rather than evidence against it. This is a serious scientific objection, but here is what makes the planetarium hypothesis more than just a thought experiment. It is the limit case of a more general principle, that we should not assume our instruments are giving us an unmediated picture of reality. Every SETI search we have ever conducted has assumed that the cosmos we observe is the cosmos that exists. It has assumed that the silence in our radio telescopes corresponds to silence in the actual universe. It has assumed that the absence of detectable technosignatures means the absence of civilizations. The planetarium hypothesis asks, what if we are wrong about that assumption? What if the most advanced civilizations in the universe have developed techniques for masking their presence? Not just from our radio telescopes, but from every instrument we could conceivably build with our current technology. Not a simulation, necessarily, but active concealment, deliberate cloaking. A civilization so far beyond us that hiding from our detection methods requires no more effort than hiding a single photon from a specific detector. We would not see them. We would not hear them. They would be everywhere, and our instruments would tell us the universe was empty, and our instruments would be right in a narrow technical sense, while the reality around us was something completely different. There is a class of theories in the deliberate silence category that does not require malevolence, benevolence, transcendence, or deception. It requires only a specific kind of game-theoretic caution that can be derived from first principles. It is sometimes called the berserker hypothesis in its darker form, but the underlying logic also appears in a less violent variant that researchers call the predator-prey model, or simply the caution hypothesis. The reasoning begins with a question. What would happen in a galaxy that contained even one genuinely hostile, expansionist, and powerful civilization? The answer from evolutionary game theory is that such a civilization would not need to destroy every other civilization directly to silence the galaxy. It would only need to exist and be known to exist. The mere possibility of a cosmic predator, even a single one, even one whose location was unknown and whose intentions were uncertain, would create selection pressure across every other civilization in the galaxy. The civilizations that loudly broadcast their existence would, over time, be the ones that were found and neutralized. The civilizations that went silent would be the ones that survived. Natural selection does not require intention. It does not require a galactic conspiracy. It only requires differential survival rates. In a galaxy with even a small number of hostile entities, silence is a survival trait. And the civilizations we inherit from billions of years of galactic history are the ones that learned silence. This is the caution hypothesis at its most elegant. It does not require that every civilization be afraid of every other civilization. It requires only that the civilizations that survived are the ones that adopted caution as a default policy. The survivors are the quiet ones. The broadcasters were found, and Earth has been broadcasting for 100 years. Whether anything found the broadcast and decided to act, whether the 100-year-old sphere of radio leakage expanding from our planet has already reached something that is now, slowly, considering its response, is a question that no one can answer with certainty. But the people who think seriously about this question tend to agree on one thing. The answer will not arrive before our signals do, and our signals are already 100 light-years out. In 2025, researchers at the International Astronautical Congress in Sydney voted on the most comprehensive update to the protocols for responding to a confirmed alien signal in the 36-year history of those protocols. The update was motivated in part by a recognition that the landscape of the question had changed fundamentally since the original protocols were written in 1989. The original protocols were written for a galaxy in which alien contact was an abstract possibility. They assumed a relatively simple scenario. A radio signal arrives. It is verified as artificial, and a set of agreed procedures determines how humanity responds. The updated protocols reflect a more sophisticated understanding. They recognize that contact, if it comes, may not look like a radio signal. It may not look like anything we have protocols for. It may be a gradual accumulation of anomalies, things that our instruments detect that do not match any natural explanation, that accumulate over years into something that cannot be explained as coincidence. Or it may be something we have already seen and dismissed. The WOW signal. Detected in 1977 by astronomer Jerry Ehman at the Big Ear Radio Telescope in Ohio. A narrowband radio signal at the hydrogen line frequency, exactly the frequency theoretically predicted to be optimal for interstellar communication, lasting 72 seconds and never repeating. Ehman circled it on the printout and wrote a single word in the margin. 48 years later, the WOW signal has not been explained. It has not been reproduced. It remains an anomaly in the data, a single data point that is consistent with the hypothesis of an artificial transmission and inconsistent with every natural explanation that has been proposed for it. Maybe it was nothing. Maybe it was instrument noise, or an unusual natural phenomenon, or a human source we failed to identify. Maybe it was a civilization that looked toward our sky, sent one pulse of signal in our direction, and waited to see if we would respond. And when we did not respond, because we did not even understand what we had received until we reviewed the data later, maybe they concluded that we were not yet capable of communication and moved on. Maybe the wow signal was the doorbell and we were not home. One of the most philosophically rich theories in the deliberate silence category is one that focuses not on what aliens are afraid of or what they are waiting for or what they have become, but on what they know about us. It is sometimes called the quarantine of violence hypothesis, or more simply, the ethical distance hypothesis. Its logic is not complicated. Look at Earth, not through the eyes of an astrobiologist who is excited by the presence of oxygen and methane and liquid water. Look at it through the eyes of an observer who has been monitoring our radio and television emissions for the past century. What have they received? 2 world wars, detailed accounts of industrialized genocide, the radio broadcasts of the Nuremberg rallies, the test detonations of nuclear weapons, more than 2,000 of them, their electromagnetic signatures detectable from a significant distance, news coverage of ethnic cleansing and famine and environmental destruction, the growing electromagnetic signature of a planet that is visibly destabilizing its own climate. And alongside that, the plays of Shakespeare, the symphonies of Beethoven, the arguments of philosophy, the debates of democracy, the achievements of science, the voices of people reaching toward one another across difference. An observer watching us from outside would see both, the violence and the beauty, the destruction and the creation, the species that split the atom and the species that wrote Hamlet, the civilization that built Auschwitz and the civilization that built Hubble. What would a sufficiently advanced, sufficiently ancient civilization conclude from this picture? Some researchers in the SETI community have proposed that the ethical distance hypothesis might be the most honest resolution to the Fermi Paradox. That the silence is not a zoo policy or a game theory calculation or a physics-motivated dormancy, but a moral judgment. Not a harsh one, a cautious one. The judgment that a species which has not yet demonstrated the capacity to govern its own destructive tendencies should not, in the interest of the species itself or of anyone it might encounter, be handed the keys to the cosmos. Not yet, not until it has proven, in practice, not in rhetoric, that the wisdom has caught up with the power. On Earth, we have strict protocols about the introduction of invasive species into ecosystems. We do not allow every organism to migrate wherever the conditions are favorable. We recognize that unchecked introduction can be catastrophic for existing ecologies. Perhaps the galaxy has similar protocols. Perhaps the question is not whether we are interesting or whether we are capable of contact. The question is whether we are safe. Let us talk about something that very few people in the SETI community discuss publicly, but that a number of researchers have written about in guarded terms. The possibility that the deliberate silence is not just about us. The possibility that the silence is a lesson. This idea appears in various forms in the literature of cosmological philosophy, and it rests on a specific reading of what an ancient, wise civilization would do with a universe full of younger, developing ones. The universe is, by some estimates, near the beginning of the epoch in which intelligence will dominate it. The stars that are favorable for life, the long-lived, stable, medium-mass stars like our Sun, are not the first generation. They are among the generations being produced now and in the near future. The universe is, in this sense, growing more favorable for complex life over time, not less. We may be among the first wave of technological civilizations in a cosmos that will eventually be full of them. If that is true, then the behavior of the first civilizations, the ones that emerged billions of years ago and have been in the cosmos long enough to develop genuine wisdom, may be shaped by an awareness that they will be observed, that what they do and how they behave will set a precedent that younger civilizations will learn from and eventually imitate. In this picture, the silence is not a strategy. It is a demonstration. The oldest civilizations in the galaxy are silent, not because they are afraid, or because they are waiting, or because they have transcended, but because they have decided that silence is the virtue they most want to model. They know we are watching. They know that what they do will shape what we become. And they have decided to show us, through their own restraint, that the most advanced civilizations in the universe are the ones that choose not to dominate, that choose not to expand without consent, that choose to let other minds develop in their own direction, at their own pace, without the distortion of an overwhelming contact with something so far beyond their current capacity to integrate. This is, of course, an extraordinarily optimistic interpretation. It assumes that the advanced civilizations of the galaxy are not just technologically sophisticated, but morally sophisticated in ways that we can barely imagine. It assumes that billions of years of development have produced wisdom rather than merely power. Whether that assumption is justified is a question that is genuinely open. There is one more theory in this category that deserves serious attention. It is the most recently developed and arguably the most technically rigorous. It comes not from philosophy or science fiction, but from the mathematics of information theory. And it was proposed in a paper published in 2024 in the International Journal of Astrobiology. The theory proposes a specific mechanism by which advanced civilizations might conceal themselves, and it uses as its foundation the most counterintuitive branch of modern physics: quantum mechanics. Classical communication, radio waves, laser signals, electromagnetic radiation of any kind, is broadcast. When you transmit a radio signal, you send it in all directions, or at minimum, in a wide enough beam that unintended receivers can detect it. The signal leaks. The cosmic radio bubble expanding from Earth is not intentional communication. It is leakage. Quantum communication is fundamentally different. When two quantum systems are entangled, they share a connection that allows information to be transmitted between them in a way that is, in principle, completely undetectable by any third party. The transmission does not exist in the form of electromagnetic radiation that leaks into space. It is a correlation between the quantum states of two systems that can only be read by the parties who share the entanglement. The 2024 paper proposed that sufficiently advanced civilizations might have developed quantum communication technology that leaves no electromagnetic signature whatsoever. They might be communicating across the galaxy right now, exchanging information at frequencies and in modes that our instruments could not possibly detect, even in principle. In this scenario, the silence is not evidence of absence. It is evidence of advancement. The civilizations we cannot find are the ones that have already transcended the primitive, noisy, broadcast-based communication that we are still using. They are communicating through the quantum fabric of reality itself, invisible to every radio telescope and every optical SETI instrument ever built. And the civilizations that we might be able to detect, the ones still using radio, still broadcasting, still leaking their electromagnetic signatures into space, are, by this theory, the young ones, the early ones, the civilizations that have not yet learned to be quiet, We are among them, broadcasting our existence, young and loud in a galaxy that has been practicing silence for 1 billion years. Now, let us confront the hardest version of the question. If any of these theories are correct, if the silence is deliberate, if we are being watched, if we are under some form of quarantine or protection or patient observation, what does that mean for us, right now, at this specific moment in history? Because this is not an abstract question. We are actively engaged in behavior that is directly relevant to the deliberate silence theories. We are broadcasting. We have been broadcasting for a century. Our radio bubble is 100 light years in diameter and growing at the speed of light. Several times we have sent deliberate signals, messages aimed at specific stars containing information about our biology, our mathematics, our location. The Arecibo message transmitted in 1974 toward the globular cluster M13. The cosmic call signals transmitted in 1999 and 2003 toward nearby sun-like stars. Messages from several subsequent Métis projects. In 2025, the debate within the SETI community about whether to continue sending deliberate messages is more fractious than it has ever been. A paper circulated at the 2025 International Astronautical Congress argued that passive listening was already a form of active engagement, because any signal we detected would inevitably be followed by responses from humans who could not be prevented from transmitting. The protocols, the paper argued, could not realistically control what happened after a confirmed detection. The counter-argument, articulated most forcefully by the scientists and philosophers associated with a cluster of papers on METI ethics, is that there is a meaningful difference between accidental leakage and deliberate transmission. Accidental leakage is a consequence of our technology. Deliberate transmission is a choice. And choices carry moral weight. If the dark forest hypothesis has any validity, even partial, even as a possibility, then the moral weight of deliberate transmission toward unknown stellar targets is substantial. You are not just communicating on behalf of yourself. You are communicating on behalf of every living thing on this planet, without their consent, in a cosmos whose rules you do not fully understand. The astrophysicist David Brin, who has spent decades thinking about these questions, has argued that the precautionary principle should apply here with unusual force. In most situations, the precautionary principle says, when the possible harm is severe and the uncertainty is high, err on the side of caution. The possible harm of accidentally provoking a hostile response from an advanced civilization is, by most estimates, existential. The uncertainty about the nature of any civilization that might receive our signal is total. The precautionary principle applied rigorously says, stop shouting. Stephen Hawking, in the last decade of his life, agreed. He argued publicly and forcefully that attempting to communicate with extraterrestrial intelligence was not a scientific question. It was a strategic one, with survival stakes. He compared it to the behavior of indigenous peoples who lit signal fires on beaches to attract the attention of ships on the horizon. Sometimes those ships were traders. Sometimes they were not. But here is the counter-argument, the one that keeps the METI programs running and keeps the debate alive. If the deliberate silence theories are correct, if there is a galactic community of advanced civilizations that has chosen to remain silent toward younger species, then the only way to change that situation is to demonstrate clearly and unambiguously that we have developed to the point where contact is appropriate. What would demonstrate that, not just technological capability? The galaxy is presumably full of civilizations that developed radio and spaceflight and then destroyed themselves. Technology alone does not qualify. Perhaps the demonstration required is ethical. Perhaps the quarantine, if there is one, will be lifted not when we send the first probe to another star, but when we stop poisoning the atmosphere. Not when we reach a certain energy output, but when we solve hunger. Not when our instruments become sensitive enough to detect alien signals, but when we become wise enough to deserve the answer. In this reading, the silence is not passive. It is a challenge. The absence of contact is not a punishment or a protection. It is a test. And the test is not of our intelligence. It is of our character. There is a number that is relevant here, a number that sits at the center of the Drake equation, the famous formula for estimating how many technological civilizations might exist in the Milky Way. The number is L, the average lifespan of a technological civilization measured in years. Frank Drake included L in his equation in 1961 because he recognized that it was the critical variable. You can have billions of habitable planets. You can have a high probability of life developing and a reasonable probability of intelligence emerging. None of it matters if the average civilization destroys itself shortly after developing the technology for interstellar communication. Drake's original estimate for L ranged from a few hundred years to millions of years. The pessimistic value, a few hundred years, would mean that at any given moment, the galaxy contains almost no technological civilizations at all, because each one flashes briefly and then goes dark. We are, at this moment, roughly 100 years past our first radio transmissions. We are, in the context of the Drake equation, 1 century old. And in those 100 years, we have developed the capacity to end all complex life on Earth several times over, using weapons that remain active and deployed and theoretically usable by political processes that are, at best, imperfectly rational. The Great Filter is a concept related to Drake's L. It was proposed by economist Robin Hanson in 1998. The idea is that somewhere between the formation of a star and the emergence of a spacefaring civilization, there is a filter, a barrier so difficult that almost no species gets through it. The evidence for this filter is the silence itself. The silence tells us that almost no civilizations reach the stage where they can communicate across interstellar distances and survive long enough to be detectable. The terrifying question the Great Filter poses is the filter behind us or ahead? If it is behind us, if the filter is the emergence of eukaryotic cells or multicellular life or some other improbable step in biological evolution, then we are fortunate. We have passed the filter. The hard part is behind us, and the future may be genuinely open. But if the filter is ahead, if the barrier that prevents civilizations from lasting long enough to be detectable is something that technological species routinely face and fail to survive, something that we have not yet faced at full intensity, then the silence is a warning. The quiet in the sky is the aftermath of countless civilizations failing the test that we are currently approaching. The silence might not be because everyone is hiding. It might be because almost everyone is already gone. And this is where the question of deliberate avoidance and the question of civilizational survival converge in a way that is important to hold in mind simultaneously. The theories that say aliens are hiding from us, whether out of fear or ethics or caution or transcendence, are not in conflict with the possibility of a great filter. They are consistent with it. If a filter exists, if civilizations regularly fail to survive their own technological development, then the civilizations that have survived to become ancient and silent are precisely the ones that developed the wisdom to exercise restraint, the ones that chose not to dominate, the ones that recognized the difference between power and wisdom. the ones that learned somehow to live within limits. And those civilizations looking at us, a species that has developed nuclear weapons and climate change and social media algorithms within the same century that it developed antibiotics and the Hubble Space Telescope, might have very good reasons for the judgment that we are not yet ready. Not that we are hopeless, not that we are being given up on, but that we are in the middle of the test. The outcome is genuinely uncertain. In 2025, a study published by researchers at the SETI Institute used advanced modeling to ask a question that had never been formalized before. If an alien civilization with technology similar to ours were observing Earth, what would they have learned about us from our electromagnetic emissions over the past 100 years? The answer was detailed and, in certain respects, alarming. Our radio emissions are detectable from up to 12,000 light-years away under optimal conditions. Our atmospheric chemistry, in particular the increasing concentrations of nitrogen dioxide from industrial processes, has become measurably more anomalous over the past 50 years in ways that a sensitive instrument could detect. But the most significant finding was about what our emissions say about us, rather than simply that we exist. Our radio and television signals contain content. They are not just noise, they are structured, patterned, information-carrying signals that encode, among other things, the content of human civilization. The wars, the broadcasts, the news, the entertainment, the propaganda, all of it, leaking into space at the speed of light, readable in principle by any civilization with the right instruments and the necessary cryptographic capability. An alien civilization monitoring our electromagnetic output for the past century would know a great deal about what we are. They would know about our politics and our conflicts. They would know about our weapons and our environmental record. They would know about our art and our science. They would have formed a picture of us. And the question of whether that picture is sufficient to warrant contact, whether what we have shown the galaxy about ourselves in the past 100 years is sufficient to earn a response from something that has been watching far longer than we have been broadcasting, is a question that no scientist can answer. But it is a question that every one of us can sit with, quietly, in the dark. What do we actually do with any of this? The deliberate silence theories are not, for the most part, scientifically testable in the near term. They make predictions. The silence will continue. No clear signal will be detected. Our searches will come up empty. But those predictions are indistinguishable from what we would expect if aliens simply did not exist. The theories are consistent with the data, but not uniquely explained by it. This is a genuine limitation. Science operates by falsifiability. A hypothesis that cannot be tested is philosophy, not physics. But philosophy is not worthless. The deliberate silence theories taken together do something important that pure absence theories do not. They make us look at ourselves from the outside. They invite us to ask what we look like to an observer who has been watching from a distance, without interference, for a very long time. That observer, if it exists, has seen us in our worst moments and our best moments simultaneously. It has seen the Holocaust and the moon landing. It has seen children dying of preventable diseases and children learning to read. It has seen the instruments we have turned on the cosmos, the Hubble, the JWST, the radio telescopes of SETI, and the instruments we have turned on each other. It is watching right now as we face a convergence of threats: climate, weapons, inequality, ecological collapse, that will determine whether we are the kind of species that passes the filter or fails it. And it may be that the silence is the most honest response possible to that observation. Not a message, not a greeting, not a warning. Just silence, saying with that silence exactly what needs to be said. The question is whether we are mature enough at this particular moment in history to hear it. There is a specific year that some researchers point to as a potential inflection point. The year 2041, when NASA's Habitable Worlds Observatory, if funded and built on its current timeline, could begin examining nearby Earth-like planets for biosignatures. When the extremely large telescope, currently under construction in Chile, will have been operational for over a decade. When our capacity to look outward will be incomparably greater than it is today. If we detect biosignatures on another world in that window, and then detect technosignatures, electromagnetic signals that cannot be explained as biology, the question of deliberate avoidance moves from the philosophical to the immediately practical. Because here is what we would face in that scenario. We would have found a civilization. We would know its approximate location. We would know that it was technologically capable, at minimum, of radio communication. And it would be silent toward us. Not because it didn't know we were looking, but, if the deliberate silence theories have any validity, precisely because it knew. In that moment, the SETI protocols that the scientific community updated in 2025 would be tested. The commitment to transparency, to immediate disclosure, to coordinated international response, all of it would face the reality of a world in which governments, militaries, and religious institutions were simultaneously confronting the news that they were being watched. And the question that no protocol can fully answer would be in the air, everywhere. What do we do now? Do we respond? Do we broadcast directly at the source, loudly and clearly, and demand an answer? Do we send the full content of human civilization into the void, trusting that whoever receives it will judge us fairly? Do we adopt the posture of the quiet ones and simply listen? Or do we launch a physical mission, a probe, a chip of silicon on a light sail fired at 20% the speed of light toward the source, not to communicate, but to look? Arriving in 20 years, sending back images of what it found? Every one of these choices has implications that cascade in ways we cannot fully model. Every one of them reflects a judgment about what we are, what we deserve, and what we are willing to risk. The universe is approximately 93 billion light-years across, in every direction from where you are lying right now. It contains 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. Each star is, on average, orbited by at least one planet. The numbers are so large that they have ceased for most people to be meaningful. They are just numbers, abstract, incomprehensible, but inside those numbers there may be minds. Minds that emerged from chemistry the way ours did, that developed curiosity the way ours did, that looked up at the dark and asked the same questions we are asking tonight. And if those minds exist, and the mathematics suggests strongly that they do, somewhere in some form, then one of the most interesting things about them is that they are quiet. The silence might mean they are gone, or the silence might mean they are watching, waiting for something, maybe waiting for us to become something different from what we have been, something more careful, more humble, more honest about the gap between our power and our wisdom. Maybe the silence is the most patient form of hope that has ever existed in the universe. And maybe the day it ends, the day the sky finally answers, will be the day that we have finally, genuinely done something worth answering. Until then, they are out there, quiet, watching, and we are here, still deciding what kind of species we want to be, still in the middle of the test, still unsure which side of the filter we are on. Look up sometime when you are outside at night, and the sky is clear and the stars are out. Something out there, perhaps, is looking back, and it has been waiting a very long time. Sleep well.